The night sky is teeming with countless stars that we gaze and observe. Throughout human history, people have wondered that the stars form patterns of mythical creatures and heroes, called constellations. But astronomy still seeks to find a better way to view the universe. It's a telescope, which allowed our eyes to see distant objects that are too far away from us. In the present, modern telescopes are even powerful to have a better understanding of the cosmos, including space telescopes as well. And today, we will explore the universe in our ultimate adventure, that we will discover strange wonders and the beautiful new worlds beyond your imagination in space and time. Our journey through space and time begins high above Earth. A fragile planet has an atmosphere mostly nitrogen and oxygen, and its surface is covered by 71% of water that flows into oceans, lakes, and rivers. The perfect conditions for all abundant life to flourish. It also rotates every 24 hours. While orbiting around the star the Sun for every 365 days. As we move away from Earth, the Moon, our closest celestial neighbor, is our first stop. From Earth, the Moon can be seen from the night sky, but up close, it's just 250,000 miles, which is the only natural satellite that orbits around the Earth for every 27 days. But on its surface, where 12 astronauts once set foot, it's a dead, barren landscape, too small that lacks an atmosphere, and covered in craters, hammered and bombarded by incoming asteroids. Dark regions on the Moon are caused by flowing lava from massive impacts. It also creates eclipses, and its gravitational pull keeps the Earth stable for regular tides in our climate. And our Earth itself sits in the perfect distance, in a zone where conditions are comfortable. And it's also just one of small rocky inner planets in our solar system. So we must travel further beyond Earth to explore other worlds in our solar system. We're heading closer to the Sun. Although it was seen from the night sky to be the brightest object, Venus, named after the goddess of love, is often the sister planet because it's about the same size as Earth. Up close, it's completely shrouded in a thick blanket of dense clouds. But those dense clouds are made of mostly sulfuric acid, and the atmosphere is choked in carbon dioxide, which causes greenhouse gases to trap the sun's heat, scorching the surface to nearly 900 degrees Fahrenheit. Hot enough to melt most metals like lead. And the pressures here are 90 times greater than it is on Earth, enough force to crush a submarine, making Venus the hottest planet in the solar system. On its surface, There are signs of landscapes and volcanic activity, perhaps even lava. If humans could survive on the surface of Venus, you will literally get suffocated, crushed and baked. Nothing can survive here. Get too close to the sun, temperatures become hotter. Then there's Mercury, the closest planet to the sun, about 36 million miles. Only slightly larger than the Moon, this small planet, with its huge metallic core, is the most heavily cratered world. Temperatures in the dayside reaches 800 degrees hotter. Then at night, plunges minus 290 degrees colder. And it orbits around the sun for every 88 days. Beyond the Mercury, about 93 million miles, is our star, the Sun, which provides heat and light for all life on Earth, and dominates our solar system. And it's also a typical middle-aged star. It's a giant ball of hot ionized gas and plasma, reaching 10,000 degrees. It's so enormous that you could fit a million Earths inside, but the core within its interior reaches millions of degrees, hot enough for hydrogen and helium to convert into energy that powers the star for 5 billion years. On its surface, there might be solar flares, prominences, and sunspots, and its magnetic forces result huge eruptions. Further away from the sun, we encounter this comet, an icy body from the edge of the solar system. Occasionally gets too close to the sun. Then the heat bakes a frozen lump of rock. Then a stream of charged particles from the solar wind blows away the evaporating gases from its nucleus, forming a tail that stretches for millions of miles, making it visible from Earth. Until we travel beyond the Earth's orbit. Then we come to the last of the 4 volcano planets, often called the Red Planet, the god of war, Mars. From space, Mars looks red. That comes from iron oxide, or rust. Although it's smaller than Earth and Venus, it has a thin carbon dioxide atmosphere. As we descend through the Martian surface, it's a barren wasteland, with conditions here are cold and inhospitable, where robotic probes have been studying the dry Martian surface. But there are also signs of landscapes, canyons, and giant volcanoes. A vast deep canyon, about 4,000 kilometers long, as wide as United States, is Valles Marineris. And the huge dust storms cover the regions around the Martian surface. Until we come across the largest distinct volcano, Olympus Mons. Is 3 times taller than Mount Everest and wide as Arizona. Some scientists believed that Mars was once covered in oceans of liquid water, the conditions to support microbial life billions of years ago. And Mars is also circled by 2 tiny moons that are probably captured asteroids. Beyond Mars, we come into the border between the inner and outer planets lies the asteroid belt. Fragments of millions of chunks of rock are the leftovers from the creation of the solar system. They range in size from a pebble, others hundreds of miles in diameter. One such body, Ceres, is the largest asteroid, about the size of Texas. Some rocky fragments can sometimes dislodge from the orbits, but something must have stopped them out beyond the asteroid belt. About 500 million miles from home, we arrived at the king of the outer giant planets, Jupiter, the largest planet in our solar system. More massive to engulf 1,300 Earths inside. With no solid surface, it's entirely made of gas, mostly hydrogen and helium. Up close is Jupiter's most distinct feature, larger than the size of the Earth, the Great Red Spot. A huge, rapidly spinning storm system has been raging for centuries. While other storms in the turbulent atmosphere move around in cloud bands. Winds here can reach more than 300 miles per hour, and it has been discovered ever since after the invention of the telescope. And its mighty gravitational pull is so great, it flings asteroids in all directions. Beyond its turbulent atmosphere, Jupiter is circled by a diverse family of moons, and the 4 largest are worlds in its own right. One of them, Io, is the most volcanically active moon, with a few volcanoes spewing lava and the plumes of sulfur skyward. Another, Europa, is covered in ice that hide traces of oceans of liquid water beneath its frozen surface crust. Yet if we find water in inhospitable places in our solar system, there might be a key to life. Further out, the moon Ganymede is bigger than the planet Mercury. Beyond Jupiter, we come to the second largest planet is the jewel of the outer solar system, Saturn. Almost 900 million miles, Saturn up close is easily visible with its bright set of rings. With the same composition like Jupiter, Saturn is mostly gas. With the density so low, it will float on water. Though its ring system may look solid, but in fact, they're mostly made of billions of countless particles of frozen debris and ice. They range in size from a pebble to others bigger than houses, and they appear the remnants of a doomed moon, destroyed by the planet's powerful gravitational pull. Unlike Jupiter, Saturn is circled by a system of moons. Like this small icy moon, Enceladus is constantly spewing jets of water vapor in its south pole, is revealed by the Cassini spacecraft. Next, we approach one of Saturn's largest moon. It's wrapped in a thick, orange hazy atmosphere. Titan. If we could descend through its nitrogen-dense atmosphere, Titan's surface is nothing but there are oceans of liquid methane that feed in rain like the rivers. What lies way further beyond Saturn, the sun becomes so dim and temperatures drop to freezing, and it's getting really cold out here. About 1 billion miles away, we next encounter Uranus, an ice giant that rotates sideways with its ring system. Was the result of a planetary collision in its ancient past. Beyond Uranus, about 2 billion miles, is the outermost planet, Neptune. Named after the Roman god of the sea, it's another ice giant, with its blue color that comes from methane gas, and its violent winds can also reach 1,000 miles per hour. We come to Neptune's largest moon, Triton. On its surface, there are geysers, spewing out plumes of nitrogen gas. It's revealed by the Voyage spacecraft in 1989. And it mysteriously orbits around Neptune in the opposite direction, suggesting it was been captured. On the very edge of the solar system lies a belt of millions of icy objects and dwarf planets such as Pluto and its moon, Charon. Only slightly smaller than our moon, it's too small, not big enough to have its right size. With its odd elliptical orbit, the sun about 4 billion miles away is so dim, it appears just another star. In the cold distant regions in the realm called the Kuiper Belt. But Pluto is not alone. It's just one of several dwarf planets that astronomers already been discovered, like Eris. And the most distant body that we next pass through is Sedna. Then we pass the farthest known spacecraft, Voyage 1. It's traveling through the outer reaches of interstellar space. Even much farther lies a cloud of trillions of frozen comets, leftovers from the creation of the solar system. If space probes like Voyager 1 reach the nearest star, it could take thousands of years to reach there. Out there in interstellar space, that miles are becoming meaningless, we measured in light years as we travel into the stars. Beyond our solar system, after we pass a cloud of trillions of comets, We have reached into deep space that we measured in light years. Even distances are so vast, they're mind-boggling. To reach the nearest star, we're about to travel faster than the speed of light. About 4 light years away, we arrived at the nearest star, the Alpha Centauri system. If a spaceship could reach the Alpha Centauri system, it would take 100,000 years to reach there. Not 1 but 3 stars are circling each other. About 8 light years away is the brightest star seen from the night sky, Sirius. They are often white main sequence stars, which are brighter. About 20 light years away from home is a red dwarf star of Gliese 581. Although this star is smaller than our sun, it's not bright enough to give out much more heat and light. But it's also circled by a system of bizarre planets, often called exoplanets. And there's even more out there that planets are orbiting other stars that astronomers already been discovered. However, if any of these alien planets have the right conditions, there may be possibly alien life. About 50 light years away, in the constellation of Pegasus, some of these planets, which are gas giants, orbits too close to its parent star, so its atmosphere is boiled and escaped into space by the solar wind. About 92 light years away is a binary star system, Algol, often called the Demon Star. But despite of other stars we ever encounter, we're about to understand how stars work, how they were born, shine, and they also die at the ends of their lives around our galaxy. As we cross the constellation of Orion, we're approaching this huge cloud of interstellar gas and dust, about 1500 light years away, called the Orion Nebula. Within this cloud of interstellar gas and dust is a stellar nursery, a place where new stars are born. When clumps of clouds begins to condense, its temperature becomes so high, they begin to shine, and yet there may be new solar systems. And after stars are born within interstellar clouds of gas and dust, they can shine for millions, even billions of years, emitting more energy and light. We next approach this star cluster, home to the Seven Sisters. About 7,000 light years is the Eagle Nebula. Inside are towering dark clouds called the Pillars of Creation, where stars are born within the clouds of hydrogen. However, even stars that continue to shine, but they don't last to live. About 650 light years away is a glowing ghostly cloud remains of a star like our own sun, one out of its supporting field, so they become into red giants until eventually they expel out its ionized outer layers into space, leaving a planetary nebula like this Helix Nebula, and all that remains is a small but dense white dwarf in its center. But stars also created something else that our bodies are made of. The stuff of heavy elements that are built inside them. When stars are much more massive than the sun, like this monster Betelgeuse in the constellation of Orion, are called red supergiant stars. So its core is very unstable, resulting a violent explosion that will literally tear a star apart. A supernova. About 6,500 light years away from home is a scattered supernova remnant that exploded almost 1,000 years ago, the Crab Nebula. And at its heart is an incredibly dense object that is compact with neutrons, called a pulsar. It's just around 12 miles across. It spins rapidly, that blinks from the distance. About 70,000 light years, we come across this cloud of superheated gas. It's blown outward by its central but unstable star, Eta Carinae. But even there are objects that are far denser than a pulsar, so mysterious to scientists, whose unimaginable gravitational pull is the endless prison of space-time, a black hole. We encountered this black hole that was first ever discovered is Cygnus X1, where the black hole is tearing apart its companion star, while a superheated disk is sucked towards the center. And yet, it still remains a mystery. Some black holes are collapsed cores of a very massive stars, with its gravitational pull is so strong not even light can escape. Inside there is no space-time. All the laws of physics fall apart in a point of no return, which is impossible. As we continue moving outward between the vast collection of stars, we will see the enormous spiral galaxy high above. The enormous spiral galaxy is the Milky Way. It's about 100,000 light years across, containing 100 billion stars in it. Our solar system is also located in the corner of its spiral arms of the galaxy. Around the Milky Way are globular clusters that are swarms of stars, thousands or maybe millions of them, and dwarf galaxies like the Magellanic Clouds. Out beyond the Milky Way about 2 million light years is the next spiral galaxy, Andromeda. Andromeda in the Milky Way and dozens of smaller galaxies make up the local group. And beyond the local group, the Milky Way is just not the only galaxy, but it's one of swarms of other galaxies that are spiral, elliptical, and irregular, or scattering everywhere in the cosmos. Like this Virgo supercluster, about 65 million light years away. But however, astronomers discovered that galaxies are flying apart from one another. That means the universe is expanding. The huge elliptical galaxy, as we're heading, is Messier 87, has a supermassive black hole in its center. And out beyond, there are superclusters of galaxies. Each point of light that we see is an individual galaxy containing countless stars. Other galaxies, billions of light years away, could be the brightest, called quasars. They can be observed in most powerful telescopes. And in fact, there are more stars in the universe than numbers of grains of sand in all the beaches on Earth. Now, as we continue traveling much further between superclusters of galaxies, there are billions of galaxies that the universe has organized. Until finally, more than 50 billion light years away from home, we reach the outer limits of our universe. This is the observable universe. It's absolutely big. Until finally, we return back home. That we began our journey through the cosmos. And our planet itself seems small and insignificant in the cosmos. Perhaps it remains for us, the only special world to have complex life on our exploration.